Okay, we're just going to talk a little bit about, just for fun, we talked about how the salt, well, we didn't really explain exactly, what happened with the salt.
Sodium maybe reacts with with the water, with the snow being out water. The snow is just it's just frozen rain, and how the sodium, the salt will actually dissolve in water. So therefore, the salt is probably dissolving as it dissolves as melting snow.
Yeah, I think you're right. What do you think, Gerard? Yeah.
I second that. Yeah, I go along with that.
Yeah. Well, in chemistry, though, one of the main issue, and when you're first learning chemistry, you talk about chemical changes versus physical changes. Like when something dissolves, when salt dissolves in water, it's not changing the salt chemically. It's still salt because if you evaporate the water, you got the salt back, right?
Yeah, the salt becomes a solid again.
Yeah, and
The salt's changing from a solid to a liquid, and then as the water evaporates, the salt is still there and becomes a solid again.
right, kind of. It doesn't become a liquid. It actually dissolves.
Dissolves. Saline solution.
Right. Yeah, it doesn't melt.
No, it doesn't.
It's funny when kids are doing that, you're taught to teach them that you need to make an observation about what you actually see, not what you think happens. So that's a classic example. If just by doing that simple little thing, like putting salt in water and it disappears, that's an observation. But if you say, "Oh, it melted," or whatever, that's you're guessing about what it actually did.
Yeah.
So anyway, in this case, you're right. It has something to do with the salt dissolving in the surface of the ice, and it actually depresses the freezing point. It's like when you make ice cream, the old way they used to do it. Where they have an ice cream maker and they put rock salt, and that's quite shocking. Like you do that with kids. I remember we did that as a very simple experiment. They put the thermometer in the ice first, then you put salt in and they stir it and it goes zzz. It just takes a nosedive into the bottom of the thermometer. They're shocked. Like how does that happen? There's a little bit more to it than that. That's basically how it works. But in terms of this, when you're releasing the snow off of the scoop, that's not chemistry. That's really physics. And you remember the Newton's three laws of motion? I barely do, but the one that's the most important probably is involving seat belts. Like, why do we wear seat belts? What happens if you don't?
You're propelled forward and the car comes to a sudden stop.
Yeah, and you know what? That's exactly what happens here.
Yeah,
Same
concept.
principle.
Yeah, you stop the scoop suddenly, and the snow not attached to it slides right off. It's like when you knock your whiskers off of your shaver if you're not using an electric one. Same principle, right? Yeah, it's Newton's first law of motion, and you can take advantage of it. It can hurt you, it can kill you, but it can also it's very useful. Yeah. Anyway, it's good to know science. Yeah. Okay. It's nice talking to you guys, and we still got a few more days left, in Canada.
We do.
Yeah. When are you guys actually going back?
We're going back next Tuesday.
Next Tuesday.
Tuesday 28th.
28th. So you're here.
So if anyone's watching, Jared and Jim's available for clearing your driveways.
Eggs.
Competitive fees.
Yes. Fresh from Ireland.
And just an add-on to that last comment, we'd like to thank our sponsor Vince for supplying the
Equipment.
the boots and the clothes and the equipment and
Showing us how to do it.
and showing us how to do it.
Yeah, and
Thank you.
and good old Alpha the snowblower.
Yes, correct.
And it worked too,
It worked. It did.
which is always a bonus.
A big thank you to Vince.
A big thank you to Vince.
Okay, thank you guys.
Yeah.